ఈరోజు ఫిజిక్స్లో వర్క్ పవర్ ఎనర్జీ అనే టాపిక్ గురించి చెప్పుకుందాం. ఇది మొదటి ఈ టాపిక్, ఇది ఫస్ట్ క్లాస్ అండి. ఈ నెమ్మదిగా మిగతా క్లాసులు కూడా వివిధ టాపిక్ల వారీగా క్లాసెస్ కూడా ఉంటాయి. అయితే దాంట్లో మొట్టమొదటిగా అసలు ఎనర్జీ అంటే ఏమిటి? ఎనర్జీ ఈజ్ defined as the capacity to do work. To do any work, energy is needed. Energy can be transformed to another form, and energy is not a substance, it is conserved quantity. That means it can be changed in any form, but it cannot be destroyed or it cannot be created. So in this part we can learn about a scalar product, that is what is a scalar product and what is vector product. First of all, I would like to tell you, first is scalar product. We can call it as dot product. That is, the dot product is a magnitude of one of the vector quantity, and it is both vector quantities, that is the dot product, and it is defined as the product of vectors and cosine angle between those vectors. And you this like this product, and I think okay, it is not seen particularly, so I will tell you the scalar product, that is p bar dot q bar is equal mod p bar into mod q bar into cos theta. Here theta is the angle between the vectors p and q. So we can find out the angle, that is theta, between these two vectors, that is p bar dot q bar is equal to p q cos theta. Cos theta is equal to p bar dot q bar by p into q. Here p and q are magnitudes, so that is we can define as mod p and mod q, so that cos theta is equal to p bar dot q bar by mod p into mod q. We can write mod p mod q as p and pq. So cos theta is equal to p bar dot q bar by p into q. So theta is equal to cos inverse p bar dot q bar by p into q. So as it follows some mathematical properties, that is commutative properties like this: p bar dot q bar is equal to q bar dot p bar. At the same time, it obeys distribution law also, that is p bar dot into q bar plus r bar is equal to p bar dot q bar plus p bar dot r bar. So here it is always a scalar quantity. The dot product is always a scalar quantity, and it is positive when theta is in between 0 and 90 degrees, and this product is that is negative. Scalar product is negative when theta is between 90 degrees and 180 degrees. So when this scalar product will be maximum, it maximum only when theta is equal to 0. That is p bar dot q bar maximum is equal to the product of magnitudes of the vectors, that is p bar q bar, that is product mod p into mod q. So here p bar dot q bar is equal to p bar into q cos theta, or q into p cos theta. So why I am telling this like this? So it termed as a different aspect, and we can explain this in different way. So here, if the scalar product, I have already told you, if the scalar product is 0, then the angle between those two vectors is 90 degrees. You can just, it is a mathematical calculation. So p bar dot q bar is equal to p into q into cos theta, here cos 90 degrees, that is equal 0. At the same time, the scalar product of any vector with the same vector is uh, it is a self dot product we can define, and it is given as p bar dot p bar is equal to, here p dot p cos theta, when theta is equal to 0, it termed as p square. So like that, for unit vectors, the product dot product of unit vectors becomes 1, and that is, we can suppose if n bar is a unit vector, then n bar dot n bar is equal to 1. Like that, I bar dot I bar, j bar dot j bar, k bar dot k bar. Here I, j, k are the unit vectors along 3 axes x, y, z. So here I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. For different unit vector, the product is 0. That is, I dot j is equal to 0, j dot k is equal to 0, k dot I is equal to 0, because the product of the angle between the two that unit vectors I, j and j, k and ki becomes 90 degrees, so that the scalar product becomes 0. Okay. For example, for the examples of scalar product taken as the scalar product of force and displacement, it is already we can familiar with this product, that it is known as, that is work done. Dot product between force and velocity, it is termed as, it can be called as power. So the dot product of magnetic induction and area gives as magnetic flux. So this topic comes in the particular subject, but here we why we are discussing here, that because it is the scalar product, for telling, for expressing Taylor, it is scalar product, so that we can I am explaining this, that is d pi is equal to b dot ds. So here pi is a flux, so pi is equal to integration b dot ds. So the dot product of current density J and area ds gives electric current. So electric current here di is equal to J dot ds. Current, electric current, that is I is equal to integral J dot ds. Here J is the current density and d is the area, I is the current. So di it denotes a small component of current. So whenever taken overall, we can take I is equal to integration, I is equal to integral j bar dot ds bar. So electric potential, like that, electric potential is also a scalar product of that is electric field intensity and position vector dr. So it also comes in a different topic. Okay, here dv is equal to minus e bar dot dr. Again integrate this, v is equal to a minus integral e bar dot dr bar. So like this, another example, that is, if a magnetic field, if a magnetic dipole of momentum of m is in a magnetic field of induction B, the potential energy of the dipole is given as UB is equal to minus m bar dot d bar. Okay, so whatever I am telling, it is all about scalar product, and it is, here are the above are the examples. Okay, like that, some more examples and problems we can denote, I will give next class. So okay, thank you very much.